right, T-clock is rolling. We are less than 16 minutes away.
All parties on net. This is the go, no go poll for launch. Please provide concurrence to proceed in the launch countdown with go, no go. VC go. GC1 go. GC2 go. Ground go. AVI go. FTS go. RF go. GNC go. Flight software go. Thermal go. Prop 1 go. Prop 2 go. Fluids 1 go. Fluids 2 go. Loads is go. Rock, ranges go. OSM, RC go. Vehicle is go. CE is go. LC is go. All parties have reported go for launch countdown. Once the clock begins to roll, anyone can call for a hold at any time. A hold is called prior to T-minus 70 seconds. The T-clock will continue to roll until T-minus 70, at which point a hold will automatically be initiated. A hold is not possible after T-minus 70, and any hold call after that will result in a terminal count abort. Should a hold manual be necessary, the person calling for a hold or abort should state clearly on comms, hold, or abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and RC on primary net.
And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Let's take a moment to introduce you to our Mission Control team. Clay Walker, who you just heard, Launch Director. John Wiswall, Launch Conductor. James Harris, Chief Engineer. Elijah Escobedo, Vehicle Controls. Brian Batters and Zoe Dickard on Ground Control. Bill Stack, Ground. And Joy Mosdell, Range Coordinator. These are a few notable members also from leadership are supporting today's launch here at Launch Control. And this includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of CAPE Operations, Pat Svatek. These are among the many, many others who are making today's launch happen. Let's go ahead and take a moment to pause and listen in for any other updates from Mission Control.
I think while we wait, maybe for our new viewers, let's give them a little bit more info about the systems that we're seeing on the pad once again. So the rocket rolls out of the hangar horizontally and is then lifted vertically by the transporter erector. That's the black vertical truss structure that you see behind the rocket there. The 4 large towers surrounding the pad make up our lightning protection system. They protect the vehicle from any direct lightning strikes. Inside of those, you'll see 4 small black posts around the pad called rainbirds. They're used for acoustic mitigation for the rocket and do so by covering the pad with water to dampen the reflected acoustics at liftoff. The small flame that you see there at the bottom right hand of your screen was once again the flare stack. No need to worry, this is perfectly intentional. It burns off flammable gases from propellant loading, venting operations, and priming of the engine igniters. It's a little harder to see, but the small slide-looking structure beneath the vehicle is our water-cooled flame diverter. It's used to mitigate the heat from lighting the engines, and it directs exhaust plumes away from the vehicle. You might also be able to see in this view 3 different levels under the rocket. So the largest and lowest level is the pad deck, and directly above it is the launch table. So this is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the transporter erector. So it transfers loads into the pad deck during hot fire tests and engine ramp up at launch. It also contains the relief system or hold downs and the quick disconnect or QD carriages that provide propellant and other commodities to the vehicle when it's on the ground. I do once again want to give a big shout out to the ground crews out here for all of their hard work. They've helped us build and operate this launch infrastructure and supported vehicle integration and testing. And of course, they helped us prepare the vehicle again for this third attempt. So thank you all so much for all of your incredible work. We did just get an update that, according to our latest weather balloon data, upper level winds are currently go. So the T clock is going to continue to roll.
Minutes, countdown sequence has started.
There you go. We are just 10 minutes away from this historic launch.
Filling propellant supply targets.
We're currently at T-minus 9 minutes and 20 seconds. Now, in the next few minutes until launch, you'll hear call-outs from our engineers and mission control as we go through the final procedural steps before liftoff. We'll be pressing the tanks, priming the igniters, doing the final engine checkouts, retracting the strongback, and then getting that final go for launch. We're currently proceeding with the launch time of 11:25 Eastern. That is 23:25 Eastern. Let's continue to listen in.
Stage 1 pneumatics and transition to helium.
All right, we're pressurizing the propellant tanks to flight pressures with helium. As a reminder, during flight, we'll pressurize the tanks using autogenous
For engine chill.
pressurization. As you can see from these epic views, we are launching at night today, but in terms of our vehicle, it doesn't make a difference if we're launching during the day or at night. The systems operate the same. You are able to see those white clouds a little bit more clearly now. So that big white cloud you're seeing come out of the strongback is due to strongback chill operations. So we're chilling all of the ground equipment to try to get our locks as cold as possible for stage 2. Those smaller white clouds that you saw earlier coming out of the vehicle at different levels are due to the venting of the chilled gas from the rocket. And that venting into the humid Florida air out here is what causes the gas to condense into vapor and look like clouds. You can also see the frost on the rocket and what looks to be small white pieces falling off. That's all just ice, and it's because of the chilled propellant inside. It's so cold that you'll see ice falling off the vehicle.
Stage 2 igniter is configured for priming.
Well, let's walk through the launch timeline now that we're getting closer.
Yeah, at T-minus 70 seconds, the vehicle will go into terminal count, and this is when the vehicle's internal flight computer takes control of the countdown. We'll then go into final flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operation safety manager. At T-minus 6 seconds, we're going to see that blue fire and have ignition of those 9 beautiful 3D printed Aeon 1 engines. And then at T0, we will have liftoff and Terran 1 will fly. Shortly after, at T plus 2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly. And then at T plus 12 seconds, we'll begin our pitch over program. So we'll go downrange in an easterly direction over the Atlantic Ocean. And then at T plus 80 seconds is that very important milestone of max Q, where the structural loads on the vehicle are the highest.
At approximately T plus 160 seconds, we'll get to main engine cutoff, or MECO, where the stage 1 engines will shut off. This is followed shortly by stage separation, and the Aeon vacuum engine will ignite on the second stage. Second stage will burn for a little under 5 minutes. Then at approximately 463 seconds, we'll get to second engine cutoff, or SECO. We'll go ahead and tune back in to mission control.
Flight computer and vertical leveling.
As a reminder, GLHF is our maiden launch, so what we're really looking for here is to learn as much as possible and demonstrate the product concept. The big milestone will be reaching that point of maximum dynamic pressure, or max Q.
Stage 1 igniters are priming in. Pressing stage 2 igniters to flight target.
We're now priming those igniters with gaseous oxygen and gaseous hydrogen. In just about 30 seconds, we're going to be looking for the transporter erector cradle to disengage.
Stage 2 is on internal power. EE cradle disengaged.
All right, now those cradle arms are going to slowly release stage 2 so the strong back can retract. You can see the arms opening up there.
Stage 1 TVC checkouts running.
And now you'll be able to see the stage 1 engines gimbaling or tilting, as you see, while we're completing those final thrust vector control health checks.
Stage 1 is on internal power.
The strong back will be retracting shortly here.
Strong back is retracting.
Here you go. We're retracting that black truss structure to prepare for
Stage 2 TVC checkouts.
for umbilical separation now that both stages are on internal power. And now we're doing those final thrust vector control health checks on the upper stage.
Starting final review of launch commit criteria.
Wow, we are very closely approaching T-minus 1 minute. I just want to remind all of us here that what you're looking at on your screen is 85% 3D printed, and it is about to fly. Next up, our range coordinator will ask the range for their final status.
Rock, report range status.
Range green.
That was confirmation. The range is green for launch.
Propellant closing out.
Flight computer configured for launch.
Under 1 minute.
LD, are you go for launch? LD, go for launch.
There's that final go for launch. We are just over 30 seconds away until the maiden launch of this vehicle. Good luck, Terran 1, and have fun. Here we go.
Ten, 9, 8, 7, 6, 4, 1. Lift off.
Terran 1 has cleared the tower.
Control maneuver starting. Proceeding to launch pad safety.
Look at that blue fire! If you can hear me over the cheering, the vehicle is now headed downrange in an easterly direction over the Atlantic Ocean. Our next ascent milestone is max Q, around 80 seconds.
Terran 1 is supersonic. Get telemetry switch over at the ground station. Max Q.
We are on our way to making a new history. Terran came ready to play today. You just heard that call out indicating Terran 1 just made it through. Max Q. We just completed a major step in proving to the world that 3D printed rockets are structurally viable. Up next, we'll be looking for a call out that stage 1 performance is nominal. We were waiting for MECO and upper stage ignition. This means that we had a main engine cutoff for stage 1, and directly following that we had second stage ignition, which you can see the Aeon vacuum engine in that beautiful view in the night sky. Reminder, there is no fairing for this maiden launch as we don't have a customer payload, but we do instead have a memento of the first ever circular test print. We are currently standing by for an update on what's happening with the stage 2 engine.
Announcement on countdown. This is the LD. There has been a T plus anomaly with stage 2. LC, please begin anomaly procedure section 25. Copy.
Do you want me to summarize? As you heard from our launch director, we did have an anomaly with stage 2 during flight. But maiden launches are always exciting, and today's flight was no exception. Although we didn't reach orbit, we significantly exceeded our key objectives for this first launch, and that objective was to gather data at max Q, one of the most demanding phases of flight, and achieve stage separation. Today's flight data will be invaluable to our team as we look to further improve our rockets, including Terran R.
Our team will now carefully analyze this data to determine what led to this outcome. So stay tuned to @RelativitySpace on Twitter and relativityspace.com for additional updates in the days and weeks ahead.
I want to thank the entire Relativity team for all of their hard work in getting us to this point. No one's ever attempted to launch a 3D printed rocket into orbit, and while we didn't make it all the way today, we gathered enough data to show that flying 3D printed rockets is possible.
As Arwo mentioned, we will apply the lessons learned today in our future vehicle, Terran R. What we are doing has never been done before, but it is undoubtedly a worthwhile endeavor that will transform the aerospace industry forever. And with that, we will conclude our coverage for tonight. I am Rachelle Aniceto. It has been an honor.
And I'm Arwa Tizani Kelly. Thank you, and see you next time.